The Renewables Grid Initiative. Who are we? We're an NGO based in Berlin, and we work together with transmission system operators, TSOs, and non-governmental organizations, NGOs, from across Europe. We are currently 26 members, plus 2 supporting members from across 12 European countries. And we work together on different topics, from the technical side of the energy transition, so the system integration of renewables into the grid, and the technical side, the environmental side, so the offshore grid, offshore renewables, but also onshore, looking at how the grid interacts and how onshore wind and solar interact with nature, and also the social side of things, so public participation, transparency, and fairness of the energy transition as we move forward to achieving full decarbonization in line with the Paris Agreement. So this topic is a new one of ours. We've not really talked so much about resilience, aside from a very successful conference that we held earlier in the year. But we decided to fit it into this energy webinar series of ours because we've recognized just how important this topic is for all of us, wherever we are in Europe, wherever we are in the world. I think we're noticing that as the climate warms and as extreme weather-related catastrophes continue to increase in frequency and in intensity, there's an urgent need to reconsider how our infrastructure works, but also how it interacts with the landscape into which it's embedded. Of course, here the real headline is climate resilience, but this concept itself requires some unpacking, and indeed, it's important to underline that there is a paradigm shift ongoing. You know, we're moving from looking at the ability of infrastructure just to withstand catastrophes, such as in this case wildfires, towards considering the ability of the grid to withstand and recover from, but also reduce risk of and respond to catastrophic events. And here we're really looking at then a new paradigm of resilience. And indeed, there are a range of mitigation techniques that are available in power systems. And this was summarized in a paper in 2020 by the Institute of Electrical and Electronics Engineers. My colleague will share the link in the chat, which really then tapped into all the things that can be done along energy infrastructure to reduce risk and to increase resilience. And this goes from things like fault prevention. So here we're talking about structural hardening of the assets, managing the assets in a way which reduces risks and minimizes abnormal behavior. And this includes vegetation management. We're also looking at ignition prevention, so how to stop actually the components in the grid from malfunctioning and causing a fire perhaps. But then all the way to fire response and impact mitigation. That means also then working with authorities, perhaps using cameras on lines, machine learning, looking at protocols for mutual assistance and communication with customers. And really, this is what we want to talk about today. We want to talk about how to take the infrastructure that we have to the next level to help us all to prevent these catastrophes and to respond to them in a responsible and innovative way, and thus create a truly wildfire resilient power system. And that's the topic of today. So to introduce our speakers, this has been me, Liam Innes. And first of all, we'll jump over to the USA, where Joseph Lake from the UMS Group's International Wildfire Risk Mitigation Consortium will give us an overview of the problem and also some solution strategies building on examples from the USA, but also Australia. And he'll present to us as well, of course, the work of the working group that they do. Then we'll cross the Atlantic again back to Portugal, where a consortium of 3 groups from REN, the TSO, from whereness, who we have Rui Roda in the room, and Carlos Viegas from the University of Coimbra, will discuss then their collaboration to create a decision support system for the management of the resilience of REN's infrastructure facing the risk of forest wildfire, which we know is a big issue in Portugal. And finally, then we'll skip across the Mediterranean to Italy, where Maurizio Marini from Terna will present to us their work developing a monitoring system for power lines to increase resilience against wildfires, but not only that, also to extreme weather events such as ice, strong winds, and things like this. So That's enough from me. As I would just remind you, you are always welcome to ask questions. So please do be putting these in the chat, and we'll get to these at the end of the three presentations. And I wish you lots of fun. And I pass the word with this over to you, Joe. Please go ahead. You can share your screen.
All right. Thank you very much, Liam. I appreciate that. I should be sharing my screen now.
Yeah, looks good.
So yeah, thank you for the introduction, Liam, and thank you for the invitation to come speak with this group today. My name is Joe Lake. I am a program director for what we call the IWRMC. It's a long name. We're working on that. But essentially what this group is a partnership among utilities to deal with the wildfire challenge across the globe. And so I'll tell you a little bit about that program today, about kind of who UMS Group is overall. And then, yeah, tell you a little bit more about kind of some of the things our working groups and our participants are talking about in the wildfire mitigation space. So the overall question of how can the grid help prevent wildfires? I think Liam summed it up pretty well. There are a lot of different things going on, a lot of new technologies, and a lot of different approaches that utilities can take. And in my experience, from talking with utilities about this over the last 5 years, it's very difficult. There's so many things to consider. We view it as something that needs to be an ongoing dialogue between utilities and between the industry and other industries and NGOs like RGI, so that we can all find the path forward for ourselves that's just right for us. So, for context, I want to point out that at least in California, I've heard that the number of fires caused by utilities, if we're just looking at the ignitions from utilities, is somewhere between 3 and 10% of the fires overall. Now, that is probably lower than a lot of people think because it gets a lot of attention in the news media. But I will say some of the biggest fires that California has ever experienced many of which have happened in the last 20 years, were caused by utility infrastructure. Now, why that is, there's a lot of different reasons, but we'll get to that later. So who is UMS Group? We'll start there. We are a consulting company founded in 1989. That's our sort of primary business. We have offices in the US, here in New Jersey. In the Netherlands, we have our sister office, an intelligence center in the Philippines, and then we also do a lot of work in Australia. But we very much are a boutique consulting company. We're very small, less than 100 employees worldwide, so very focused on very specific issues. We have 3 lines of business. So general consulting is just one of them. We're an endorsed assessor for Institute of Asset Management and do training around ISO 55000 and qualification. We do a lot of work around tools development. We have a tools business. So we develop analytical tools for utilities to use to improve reliability, to improve their operational excellence overall. And then my line of business are what we call these global learning consortia, of which the IWRMC is just one. Many of you will have been familiar with ITOMS. It's our transmission operations and maintenance study, a big consortium of companies looking at transmission related issues every couple of years. So the IWRMC started shortly after the Camp Fire in California. So 2018, it was in the news, it was big news. This was a huge fire, a rapidly growing fire. It devastated the town of Paradise in California. Paradise, as you might see, is right in the middle of this fire footprint. This is the overall fire footprint here. It's sort of in a valley here, and the fire was ignited and kind of spread and took out the entire town. As I listed here, it grew to 18,000 acres in one day. It was just a massive fire, and it led to the bankruptcy of PG&E. Right, there was a failed C hook. This is actually a C hook, a picture of a C hook right here from the actual tower that they believe the fire was ignited from. This isn't the actual C hook that failed, but you can see there's a lot of wear and tear on this device. I also wanted to point out there were 13 other major fires that happened that overlapped with this footprint in the last 18 years before that Camp Fire. So a lot of this area was area that had burned many, many times and still was able to evolve into this massive fire. And I say that to point out that this was unprecedented. This was a really significant climate driven issue that PG&E was dealing with. And so we had executives in California who reached out to us and said, you know, obviously things are evolving. We have this ongoing drought. We want to start talking with other utilities about wildfire. We want to talk to other executives about how they approach this from a strategic level. And so we made the connection. We built this initial forum for 5 utilities, three in California, 2 in Australia, to start talking with each other about these things. Very quickly that evolved, and we built a more formal program around it, brought in lower level people in the organization, people with boots on the ground, directors, managers, supervisors, who could talk about what they're experiencing with each other. And so that's what the IWRMC is today. It's 20 members. As I said earlier, our mission is just to accelerate learning in this space. UMS Group, as I said, is a consulting company. We're just a facilitator. We have some subject matter expertise around asset management and utility operations, but our goal is to get utilities talking to each other and get us, we don't want to be the middlemen. Where we still have the initial team of 5 utilities serves as our steering committee, and so it's still very much utility driven. They, from sort of the top down, can say, let's make sure that we're focusing on the right diversity of topics that's going to help all of our members. But as I said, it's 20 companies now. It's not just a California thing. It's not just an Australia thing. We have members in the Southwest, the Northwest of the US. We have Canadian members, South American members, many, many Australians. And I've had many conversations with folks in Europe who are interested in talking about this because it's just a very important topic. And so we continue to grow over time. And the way we work is through 4 primary working groups. We've sort of divided up wildfire mitigation into operations focused things, sort of day of, near term, next couple of days, what does the wildfire risk look like and how are we reacting as a company? Asset management, of course, which includes all your inspection programs and your replacement programs and your interventions to repair and replace. Vegetation management, probably the biggest thing. Many companies, when they begin their wildfire journey, it starts in veg management because that's where your exposure is. And then risk management, which is kind of how do we model these risks overall and how do we put all these pieces together to bring together what we're doing in operations, what we're doing in asset management, what we're doing in veg management to put together this whole sort of strategic vision for mitigation across the company. So that's kind of how we break it up. There's other work we do, and I could go on and on. I'm trying to be brief here, but data management and governance is a huge piece of this. There's so much data coming in, especially with new technologies, new sensors. How do we manage all that data and make sure it's accurate and refreshed often, things like that? Stakeholder engagement is another huge piece. How do we talk with our customers? How do we talk with our regulator? How do we engage folks outside the industry? And that's one that we're trying to help with as well. So there's a lot on this screen. This is just a sample of topics that we've talked about. So each of these working groups meets every month. And so there are 48, 50 opportunities for folks to come together every year and talk about different topics related just to wildfire. So I wanted to flash this up because you'll notice as you look through this list, there's some overlap, right? So our asset management group and our veg group sort of separately, but around the same time decided we need to get on the same page about what we mean when we say a fire start or an ignition, because we're using different terms. And for some people, it means there's the potential for a fire. There's a single spark. For some people, there's actually an actual fire and it spread to a certain size. Basic things like that it's inconsistent from California to Oregon to Victoria or New South Wales. We all kind of define it a little bit differently. And so we've had some really great surveys and conversations about that. I'll get into a little bit more of specifics around these topics here in a minute. One thing I want to point out, this is a key element of our program. So we've developed a maturity model for utilities to assess their own capability in this space. And it was based off of some work that was done in California The CPUC developed a maturity model that they required the California investor-owned utilities to fill out every couple of years. And it was, we thought that was a great idea. Being able to kind of see where you are and where you need to go is always a great idea. And it's consistent with things like the Institute of Asset Management, ISO 55000. There's sort of a journey you go along to get to where you need to go. However, we did find some issues with it. There were some tangential things that weren't directly related to wildfire that were included that we didn't think were necessary. So we put it through the ringer of our working groups. And for about a year and a half, we discussed this model and we tweaked it and we put our own definitions down on paper about what each of these capabilities look like. We built an assessment tool, a survey that you can fill out to kind of self-assess. And we're in the process of, everyone's filled it out, and we're in the process now of validating all those results and going through it. So we're really proud of this model. The most important part about this model and the big difference between what we've done and what they do in California is we're looking at your actual wildfire risk exposure, which is this y-axis, this vertical axis on this chart here, to help determine where do you need to be as a utility. In California, it's fairly easy to say everyone in California faces a significant risk. And so we don't really need to look at what your exposure is. We're going to hold you to the same standard. If you start to look at other places, the Pacific Northwest, Australia, the Southwest, even start to get into the East Coast, of the US or into Europe, we're all going to have different risk spectrums, different risk exposures based on our vegetation types, based on our infrastructure and how new it is and how well we maintain it, based on the types of weather events we're exposed to. And that's going to change over time too, as climate change is just continuing to morph what our risk maps look like. And so we've built it in here where we said, first you start with an assessment of what your risk looks like, and that'll determine where the bounds are of your maturity, where you should be. Because if you go beyond a certain amount, if you're in a very wet climate, it doesn't see a lot of fire, but fire is a small thing. It happens at certain times a year. You might have a pretty low risk exposure and you shouldn't be held to the same standard as someone in California. It would be imprudent for you to maybe deploy some technologies or to take an approach that they're taking in California just because they're doing it in California. So we try to bake that into our model here. I'm going to skip through a few of these things because I know I could talk about this all day. This is just a snapshot of kind of who our members are. And then we'll provide this deck to you. So I hope, since I move pretty quickly, folks can reach out to me and ask questions whenever you'd like. But some key topics and some technologies that have come up within the forum and that we look at all the time. So PG&E came out and said that they were going to underground 10,000 miles of their highest risk assets. This was last year, I think maybe late in the year before. This caught a lot of utilities off guard. Now suddenly their board is asking them, or their customers are asking them, why haven't you undergrounded all of your lines? Because that eliminates the fire risk, right? So we're having a lot of conversations about that, right? How do you assess the cost versus benefit of doing that? The common trade-off that many companies are looking at is, okay, there's two really effective ways to manage your risk. One is undergrounding, and one is using a lot more covered conductor. Get rid of all your bare conductor, use covered conductor. That's much less likely to spark an ignition. So we've talked a lot about that. Many have seen very good reliability improvements from that in addition to the wildfire risk. So you got to include that in your cost benefit calculation. Climate resilience as a whole has been a huge topic for executives in particular, because they're thinking about not just wildfire, but in Australia, for example, we just had 3 La Niñas in a row. Very, very wet. Flooding has been a huge issue. Fire, not so much, but flooding, storm damage, huge issue. 3 years of that. And now we're looking towards the next couple of years. If we swing back the other way, we're spending a lot more on vegetation management. Are we going to have to continue to spend more on veg management because now everything's growing like crazy? And then if we get into a drought period, suddenly our wildfire risk is through the roof again. So kind of understanding it more holistically, not just looking at wildfire in a silo, but all of these other climate impacts is really important. Grid hardening. I wanted to focus on this. I know that's where you're going to get a lot of bang for your buck, right? What can we do overall to harden our grid? It's interesting, and as I said earlier, it looks very, very different for different companies. You have to understand your wildfire risk as a starting point, because I was talking to an executive actually just yesterday, and he said, I asked him, are you looking at undergrounding? Are you looking at cover conductor? You face pretty significant risks. And he pointed out that they have a ton of manually operated devices on their network, that every time there's a high bushfire risk day, they have to go out in the field and manually set these devices to to isolate the grid, or to trigger at a lower threshold to make sure they don't start any fires. And that's a significant investment, is a significant risk that they might miss some or isolate the wrong parts of the grid. It's not something they can adapt to very quickly. So for them, yeah, they'd love to put some cover conductor in. They'd love to underground more assets. But where they're going to get the most bang for their buck right now is going out and making sure their SCADA is deployed, making sure these manual devices are replaced with automated devices. That's what makes sense right now. And once they do that, they can start to look at what's the next step in the process. Because as you all know, we don't operate in a vacuum. We can't spend money on everything. We have to prioritize, and we have to make a justification to our customers and to our regulators to make these investments and get the most bang for our buck. So new risk areas, I'm referring to climate change. I have seen, even just in the last 3 or 4 years, the sort of line that if you draw a vertical line from the west coast of the US, where most of the fire risk has been historically, and divide that to the rest of the US where there's not as much risk, that line is continuing to move east, because climate change is causing just really erratic weather patterns. We're seeing major fires in Colorado, and as we move east, that's happening everywhere. It's not always that simple to say it's moving west to east. Sometimes it's moving inland, maybe in Australia, or moving east to west in some areas. Very, very erratic. There's lots of data out there now through the IPCC around what those impacts are starting to look like. And so utilities are starting to look at that and say, what's it look like for me over the next 30, 40, 70, 90 years? Very briefly, insurance strategies, that's going to look very different in each region. California, they have a model where they all the big IOUs pay into a fund, a wildfire mitigation fund, that they can tap into if there's a major fire and there's liability there. That's a sort of form of insurance for them. That's a very unique strategy. How do we manage our relationships with the regulator and make sure it's not a contentious thing, but a really productive, proactive conversation? That's a huge thing. And again, stakeholder engagement and engagement with their customers is another really major challenge for utilities right now. So the sort of sexy conversation is around technology, right? You all want to hear about the technologies people are using, and I think we're going to hear a little bit more from some of our other speakers later. So I won't get into too much detail, but they sort of fall into a few different categories. These are just some of the really hot button ones right now that I've seen. Situational awareness is huge for companies. You kind of have to know what's going on, right? So whether that's using cameras to just be able to see what's going on out there, using cameras to detect ignitions that are happening, or the spread of fires. Liam mentioned kind of working with your partners, say first responder organizations. In California, I know that they've done that really well. So I know San Diego Gas and Electric, they give direct access to their cameras to the Cal Fire, who can tap into those cameras and use them to monitor fires. Weather stations, knowing what the weather looks like. Sticking with San Diego, they've been dealing with this a long time. They have a world-class program around wildfire mitigation, and they held off on weather stations for a little while. And once they actually put some weather stations out across their grid, they actually found some areas. They had some mountainous areas and some canyons where they detected 100-mile-an-hour wind gusts. And they knew the wind was high up there. They knew it was a risk, but they had no idea they would get 100-mile-an-hour winds certain times of year. And so even when you think you got a pretty good handle on what your network looks like and what your exposure looks like, having that concrete data to say, I can't disagree with it, this is the situation, is really important. AI and machine learning, another huge topic. And whether that's to, like I said, cameras that are using AI to detect ignitions or figure out what's the probability that this was actually an ignition is really important. There's a company called Optech, who has, it's not even technically a camera, I guess it's technically a camera, but it doesn't look like a traditional camera. It's actually, it can detect a fire on a single pixel. It can analyze that pixel and look at the spectrum, the light spectrum, to determine whether it was actually an ignition. Doing some really innovative work, some really great work. Also seeing AI for image processing. If you're going out and inspecting your grid and doing it more frequently and taking pictures through using drones or fixed wing aircraft, that's a lot of images to go through. And so using AI to process all that information is really going to be really, really important going forward for rapidly identifying issues. I could go on forever. Down conductor detection, that's a huge thing going on right now. In Australia, they use a lot of rapid earth fault current limiters. That was mandated in Victoria that they deploy these. And the idea there is just to limit the amount of energy that's in the system when you have a conductor that fails so that you don't cause an ignition. And early fault detection, similarly, kind of reducing that energy when you have a fault, detecting it early so that you can de-energize before a fire starts. So there's a lot out there. I don't want to go on any longer, Liam, but I hope that, I welcome any of your questions, and I hope I can get to talk with each of you at some point at a future date and tell you more about what we're working on. Because like I said, I'm passionate about this, and I could talk about this all day long.
Thank you so much, Joe, for that fantastic overview. Really, I would say, well, first of all, to the audience, we will have a discussion at the end of all speakers, but if you have already any comprehension questions, just for Joe, quick ones, feel free to raise your hand now. And just in the transition, maybe I could say, I think it's a really good point you made at the start. You said, Joe, that this became an urgent topic to respond after specifically this campfire a few years back. I think if we can, in Europe, learn from the experiences before it gets even worse than the situation is, preemptively learning so that it doesn't get so bad, that would be a really, really positive step. And indeed, not even in the very fire risk prone areas. This is where I live now in Berlin. The region around Brandenburg, it didn't used to have a very high fire risk at all, but we're seeing every year more and more huge fires. I'm from England, and even in the very wet, rainy regions in England, this is also a topic that people are increasingly having to manage. So yeah, thanks again for this great overview. If there's no immediate comprehension questions, then we can already move on to the next presentation. Joe, I would ask you to stop sharing your screen, and I'll get ready to introduce the next speakers who are joining us. As I said, from Portugal, we have REN, the TSO, we have the University of Coimbra, and we have whereness. And starting us off will be José Moreira. So please go ahead, José, and share your screen. And we look forward to your presentation. Thanks very much.
I hope you can see my presentation.
It's your desktop at the moment, and now we're on PowerPoint, and it looks perfect. Yeah, go ahead.
Hi everyone, my name is José Moreira. I just want to make a small introduction about the decision system that we build up to help us to manage wildfires in Portugal. And then I will give the floor to my colleagues Rui and Carlos that will explain more deeply the system. So first of all, a small introduction about REN. REN is the TSO with operations in Chile, and our main area is Portugal, where we have more than 10,000 kilometers of gas and electricity networks, which represents more than 25,000 acres of right-of-way to manage. 60% of our right-of-way are in forest areas. Fire risk in Portuguese forests are very high, so our network is heavily impacted by this risk. We can see some image on the right for what this impact means for us. From this maps, you see small dots on the network. As you can see, almost all network is affected by wildfires. During fire season, typically in summer, we have an average of 5,000 occurrence. And in the last summer, at 30th of July, we almost had 200 occurrences in one day to manage. In 2017, we developed a system based on Azure tools that, through a connection to our National Authority Civil Protection, we call ANPC, give us in real-time information where the wildfire starts. These systems alerts field teams as well to our national dispatch and operational rooms, but this wasn't enough for us. We wanted to change and to implement more. So we became by the idea, and we also installed 8 monitoring systems that allows network monitoring. The system consists of a main camera that detects small columns and hotspots, and a secondary camera that tracks the events nearby. And also a weather station that monitors local conditions and sends these conditions to our National Weather Institute that we call IPMA. This system has solar panels, and the communication is done with fiber optics on the top of the tower. As shown in the image, cameras allow the detection of smoke columns using AI. We are training the system to detect different shapes of smoke and to make autonomous detections. We can have also time lapse, and we can seek for the first image of the fire. This is really important for us to start to know where the fire started. And also we can detect hotspots using infrared camera. From this small video, through this session, we can make pan, tilt, and zoom of the surveillance camera, the secondary camera, as I said, and see all the surroundings with good quality of image. We can also see alarms, weather condition, land elevation, and change the cam direction with a click on the map. All that in real time. So, as I said, we wanted to go further and stop focusing on the start of the fire, but on time and place that will impact our network. This is really important for us. In this way, with the help of Universidade of Coimbra and whereness, we develop a system that allows the fire propagation simulation and the graphic visualization of this simulation. Where the Universidade of Coimbra developed the scientific part, looking at where the condition, land elevation, and calculating the time and place of impact. And whereness, through the Azure products, made the graphic visualization of those lines and which asset will fire affect first. And then I will show a small video. I hope you can hear the video. As I say, it's 20 entities and 70 researchers. As I said, you see that Karim made the examples of where the camera is installed, the different zones in Portugal. So the main conclusions are we are no longer focused on the point of ignition, but on time and place of impact, on reduction of alerts, the 5 times as I said before, monitor wildfires outside the 5-kilometer buffer and make new simulations, better efficiency activating prevention teams and providing service, and the most important one, providing service to entities, helping communities, helping companies and communities. And now I give the floor to my colleague Rui Roda from whereness, and thank you all.
Okay. Thank you, Jose. My name is Rui. I'm from whereness. We are a software house for, we develop GIS solutions, geographic information solutions, and we are here in the project as integrators and also, of course, bringing the scientific part of the project to the operation, to the operational processes. Okay, so what I will show, explain here 2 slides. It's enough to explain the whole system. So what we have here is the workflow. Please, Jose, can you proceed with the clicks so the animation can work? Okay, so the system has 2 inputs, one from the national authority that manages the fires in all the continental territory, and also the cameras that Jose just showed you that are on the infrastructure. So every time we have an occurrence, an alarm, a fire alarm, the system, the first thing that it does is let me see if this fire alarm is within 10 kilometers from the infrastructure, meaning the electrical or gas infrastructure, if it is within this 10 kilometers or outside this 10 kilometers buffer. If it is outside, just discard the alarm and does nothing. If it is inside the 10 kilometers buffer, it will send the XY coordinates to EM-Fire, which is the system that makes the simulation. Jose, please, can you? Yes. So it will make a call to the service. One more two clicks, please. It will make a call to the service, and the service will make a simulation based on several inputs that Carlos will explain later. And with this, the service will return several isochronous curves, which will tell what will be the propagation of the fire in 30 minutes, 1 hour, 2 hours, 3 hours, up to 5 hours. Having these isochron curves, it will make a geographic intersection with the infrastructure that is within the GIS database. Okay, so if there is an intersection, meaning that the infrastructure very probably will be affected in this case, let's say 2 to 3 hours. It will raise a notification to the teams that will plan either redundance to keep on with the service, or go to the field to take some measures to protect the infrastructure. Even on the field, the teams can make some simulations, because when they go to the field, maybe it will take 20, 30 minutes. There was an evolution of the fire, so they want, oh, the fire now has progressed. Let's see what is the simulation for the new place of the fire. Or they can even they can also make a simulation with a fire, saying what happens if the fire reaches this point, what will be the prediction for propagation. So again, the team will make an input on the system, and again, the system will call the simulation service, get again the isochronous, and gives the results, so the team can make a new plan or take new decisions about the propagation. Okay, what I will show you is also in the project. It is predicted. It is a vision for the project that we can make this server available for the outside, for maybe companies or municipalities, or even citizens that have some assets on the forest. But currently, the system is limited to be used by hand. Okay, Jose, please, can you go to the next slide? So what we have here is a video showing the front end, the GIS front end, explaining the workflow of use for the system. Okay, so here on the right side we have all the occurrences that we had until now. Okay, We can, of course, go on the each occurrence, check what was the infrastructure, the infrastructure components that were expected to be affected. You have here on the right side the time that so the time that it is expected or it is predicted that the fire to reach these infrastructures. Okay. And of course, as I told you, you can have the inputs from the national authority, from the cameras, or you can make a simulation. That's what we can see here. So you click on the map where on the position where the fire is happening, or you think that it will be reaching this point, and you make a simulation. Of course, you have to tell if it is a real fire or if it is a fictitious situation, a non-real situation. You call the service for simulation. You can see here a green line, which is electrical infrastructure, and on the right side, on the left side, orange line, which is a gas infrastructure. So for the point that we point on the map, we have this. Okay, red for 1 hour, orange for 2-3 hours. And here on the panel on the right side, you can see the infrastructure components and the times that it is predicted to be reached. Okay, we can, well, I think there is another simulation, but this is basically the system. So I would pass now to Carlos, who will explain how the system works in terms of inputs and algorithms to make the prediction for to get the isochrons as on output. Okay, thank you, José. I think you have to do one click to pass to Carlos.
Thank you, Rui. Thank you, José. Good afternoon, everyone. My name is Carlos Viegas. I'm from the University of Coimbra. And now my part is to explain you a little bit what happens between the time that we actually send the coordinates to start the simulation and actually receiving the results of the simulation. So the isochronous lines that Rui just showed previously. So all this is done through our simulator that was developed in our house in the University of Coimbra, and as advanced wildfire, smoke, and weather models coupled with AI. So we are able to simulate not only the fire spread and behavior, but also changes in the atmosphere, production and dispersion of smoke, and many other parameters. This simulator is available as a web-based platform or as an API. Actually, the API is what is being used right now with REN. So we actually receive the inputs from REN, and we automatically provide the results without any human intervention. The simulation time is within 2 minutes, and we are constantly working on improving our models to be able to reduce this time. So, José, if you can pass to the next slide. This is the overview, the pipeline of all the process that happens in those 2 minutes. So for the input data, we receive several data types from several sources. From the user, we receive the time and coordinates of the fire ignition. And we can also receive local wind speed and direction. This is something that some clients can provide us, others don't have these capabilities. But we can also have automatic means to fetch this data from online sources. We also have in our database the maps for the terrain, the maps for the fuels. So we have a pretty good idea of the conditions in the site. And then we put this data into our models. Here we have several models for fire, for wind, for smoke, and so on. And then they allow us to have the results. And in the results, the main result is the fire rate of spread, meaning the velocity of the fire front, which allow us to say, okay, the fire is going to be here in half an hour, in 1 hour, in 2 hours, and so on. But we also can provide many more results, such as the fire line intensity and the flame height. These results give us an idea of how the fire is going to be when it reaches a certain location, and we can estimate the impact on the infrastructure from that fire. We can also decide which means we can send to that location to fight the fire. And sometimes we don't have enough means to fight the fire with a certain intensity, so we have to manage in another way. So here we can shape our strategy to better fight the fire. Smoke generation and smoke dispersion is also very important, not only for the operations on the ground, but also the operations in the air, especially operations in the air. When we are talking about fighting fire with the aerial means, smoke is definitely something that we should take into account. And everything is supported by a layer of artificial intelligence, in this case, genetic algorithms, which I'm going to explain after what is the role in this pipeline. So, Jose, if you can proceed. Concerning the input data, we use a raster approach, meaning that we divide our domain in millions of cells, 25 by 25 meters, and each cell has a set of parameters concerning the ignitions, the wind, the fuels, the slope, and the coordinates. This means that as long as we have data, we can provide simulations to any region in the world. So we are not limited to Portugal, but give us the maps, give us the data, we are able to apply our models to the United States or any other country. In the next slide is the explanation about the backbone of our simulator, which are the fire spread models. Some of these models you will find in the literature, and some of the fire simulation systems that are already available have these spread models, but others are not in the literature. They result from our activity. We have been studying wildfire behavior for more than 30 years. So we accumulated a lot of knowledge on this area, and we put this knowledge into our spread simulator so that we can have more accurate results, because we know that fire conditions have been evolving in the last years due to climate change. Conditions are not the same as they were 20, 30 years ago. So the models that were developed back then are not perfectly suitable to the real conditions that we have currently. And so we are constantly doing this effort of updating these models. Jose, if you can proceed to the next slide. So in this part, we can have the most accurate models possible, but we can always have errors in our simulations if we do not have correct input data. And this is a very critical aspect, because if we do not have accurate data concerning the fuels, concerning the wind, our simulations are not going to produce faithful results. And because of this, we are using a process that is fueled by artificial intelligence, in which we take advantage of the fact that we have cameras which are not only detecting the ignitions, but also monitoring the occurrence as it is happening. And in here, we create a closed loop where we feed the current fire parameter to our simulator, and it compares the perimeter of the fire with the simulated one. And through this, it adjusts several parameters of the simulation to produce more faithful results. Jose, if you can proceed to the next slide, we can achieve actually a 40% increase in the simulation accuracy through the use of genetic algorithms to fine-tune the simulation parameters. Of course, we are very excited with all these new tools that we are developing for the protection of our infrastructures, for the increase of their resilience, but we also have already our eyes set on the future. So right now we have, in this project, rePLANT, have accomplished the proof of concept for the project. So we know that the system is capable of providing these inputs, but we are already expanding and looking into the future with a new project, Transform, which represents an investment of more than 6.3 million euros, in which we are developing a decision support center for providing this simulation as a service for several entities. And here we are not going to be limited to wildfires, but we are also looking at other natural hazards. So in this data aggregation and analysis center, we are getting data from multiple sources, And we are providing these fire spread simulations for other utility companies, let's say railroad network, road networks, telecommunication assets, and so on. So all these critical infrastructures that need protection, that are often in fire-prone areas, they can come to us and ask for our services and our support. I think this is it from our side. I thank you very much for this invitation. It's a pleasure to be here and talking to you about this technology that we are developing. And we are available for any questions that you might have. Thank you.
Thank you so much. Thank you, Carlos. Thank you, Jose. Thank you, Rui. That was a fantastic presentation and really an excellent example of how to make this scientific knowledge useful to operational processes, in this case, of course, of the grid, but I mean, really available to many people, potentially unlimited people across the world. Yeah, thank you very much. I have seen some questions have come in, but I also know that time is marching on. So Franco and also Sebastian, you have priority when we get to the discussion. I'll give you the word, but I will jump straight to the next presentation, which is Maurizio from Terna, the Italian transmission system operator. So
good afternoon, everybody.
Over to you.
I'll try to share. Let's see if it works. Can you see the presentation? I guess yes.
That's looking good. And if you click on full screen.
Ciao, si scendo.
Yeah, if you switch the view around.
Yes, trying. No, let's do this way. Can you see it now full screen?
Yeah, looking perfect. We're on the slide with tennis history.
Okay.
Okay, thank you, Maurizio. Over to you.
Okay, good afternoon, everybody. I am Maurizio Marini, head of Digital Solution at Terna. Digital Solution is a group of people. We started in 2019, as you will see. And we deal with industrial IoT, so asset digitalization, platforms, analytics, and algorithms. So I will try shortly to describe what we have done in terms of monitoring of power lines during these years. We are delivering now a big program, and the idea it is to keep a good part of our power lines with the capability to sense the nearby environment in order to address different kind of risks. So we are thinking in terms of infrastructures. And we are developing a monitoring infrastructure, and in different cases, as we will see, we will equip with different kind of sensors in order to address different kind of risks. A short introduction of Terna. Terna, it is the Italian TSO. We manage, in terms of power lines, 75,000 kilometers of power lines, 1,000 of power stations. We have approximately 5,000 people working for us. So, and as you all know the shape of Italy, you can understand that this power lines so extended are affected by different kind of risks, depending if they are in the mountains or nearby the sea, into trees, and so on. We started our work for 4 reasons. You can see the first one, it is the extreme climate events. As somebody pointed out before me, the climate events are getting more frequent, more rapid, more brutal. We started in 2019, in fact, because we had a storm which destroyed an entire forest of several thousand of trees. And we experienced 61 faults on the power lines in 3 hours, suddenly in the same area. So you can imagine what the impact was on the operation of on the grid. In addition, we have the need to address the development of renewable energies, which of course affects the way and the speed with which we need to address the outage of the lines. We have for an impact, of course, with the electrification, and we are more and more interconnected with other TSO. So for those reasons, we started our program in order to digitalize the power lines, because the stations are already digitalized, maybe with all the SCADA system, but already working. So it is a different kind of problem. It is a problem of convergence between TOT. On the power lines, on the other side, we don't have a specific technology, and we needed to develop our own technology. As I said, we started the IoT program for power lines in order to address different kind of risk. So the idea it is to develop a standard collecting infrastructure on the power line for collecting the data from different kind of sensors in order to address different kind of risk. We started from wind, from ice, as you can see, because we started in the mountains, in the northeast of Italy. Now we are developing different kind of sensor in order to have, during the time, a catalog of sensor for keeping the pillar, in order, for example, to address the risk of saline deposit on the isolator. To address the fire, I will tell you what we are going to do this year. To identify, for example, about security, people escalating, accessing to the pylon. And also in order to manage the hotspot formation on the power line, or to manage the conduct temperature and optimize the power flow on the conductor. As I said, we do that for, first of all, for asset management, in order to develop also preventive policies and real-time solutions, in order to accelerate the failure recovery, in order to be able to know which kind of problem we have and where we have the problem on the power line. And also, last but not least, in order to optimize the dispatching of power flow, as I just said. We developed you can see we are covering the full technological chain. On the power line, as I said, which is the focus today, we developed our own technology because the market does not have standard technologies for this. So we're developing sensors where needed, and digitalizing box, which we call Digil, in order to digitalize the pillar. We develop the infrastructure for collecting the data along the lines, as 4G is not always available. Then we develop the platform, and last but not least, the algorithms and the applications. We started in 2019, starting from the problem of ice on the conductor, and the conductor falling on the ground due to the ice, for example, or some kind of object that hit the conductor, for example, as a consequence of a storm. So we have developed sensors for measuring the weight of the conductor. And we patented also this kind of sensor. We installed weather stations, accelerometer, and inclinometer on the pillar. During the following year, we spent several months in order to stabilize the availability of the devices and to enhance the data quality. In 2021, we developed the algorithms together with the business unit. Also both on the field and in the dispatchment units, in order last year to have the system in operation, which is a system which is not yet fully delivered. On the contrary, it is at the beginning in terms of delivery, but for the delivered part, it is in operation and actually used. During this year, we are preparing the scale up, and we are developing the sensor catalog, one of which it is the wildfire sensors, in order to address a new use case and to cover all the kind of risk that we identified as important for the program. How it works? There is a box, you can see the Digil one, powered by a solar panel with batteries inside, which collect all the data from the sensor installed on the pillar. The Digil at this moment, it is equipped, as I said, with accelerometer, with inclinometer, with power station, and with the weight sensor for the conductor. As we will develop a new sensor, the Digil is able to be integrated with new kind of sensors. We defined LoRa as a technology, telecommunication technology for collecting the data. We collect all the data into the IoT platform, and then we elaborate the data. We have developed the different algorithms. Already with this, correlating this kind of measures, we can address the actual use cases, but we can also calculate different secondary measures, we can say. For example, it is very useful to know the temperature of the conductor in order to optimize the flow of the power on the power line. And we developed with the University of Rome a way, indirectly, without measuring directly the temperature of the conductor, to calculate this temperature of the conductor, starting from the weather conditions and the measure of the weight of the sensor made with our sensors. So one key point it is to identify the minimum set of sensor in order with which we need to equip the pillars, and in order not to install too many things, because in our experience the main cost affecting the cost-benefit analysis it is the installation of and the maintenance of the digitalization device, which is 60% of the total cost of ownership during the 10 years of this device. So we needed to install the minimum set of things, sensor, with any kind of electronic device on the pillar, in order to be able to install, not to grow the cost too much. In fact, we have 240,000 pillars in total. Only equipping 10% of these pillars, it is a huge number. How many devices we have equipped at this moment? We have covered, as you can see, different regions, also to be able to test a different kind of use case. Approximately, we have 215 Digil equipped with 2,000 sensor collecting data at this very moment.
Sorry to interrupt you, Maurizio. You have around 2 minutes left before we need to move on to the questions.
Yes, thank you. And we are installing, for example, in Sicily and Sardinia for testing the wildfire. We are installing on the seaside to test the isolator sensor, and in the mountains for the ice. As I said, during the first year, we have different performances for the device. It took some time to set up everything in the right way in order to have a good system availability. Taking into account that this is, we have 4 different solutions. So taking into account that it is a wide POC, but a POC, we are satisfied with having a 70% availability at this very moment. And in this, as you can see, during this winter, we were able to identify several ice sleeve along the conductor. One important thing to say it is that we are able to see much more events than before, because of course the asset management is able to identify the problem along the line, the damages. Now we are able to see also the ice that it forms and it melts in the morning. In this way, we are developing new policies for asset management, which depends not only of the broken conductor, but also on the stimulation from the ice during the winter on the conductor. One last thing, so what we are going to do this year on the fire detection. We are developing some additional sensor for detecting fire based on the measuring of PM top 2.5, PM 10, carbon monoxide, and carbon dioxide. Temperature, pressure, and humidity we already have from the actual weather station. Based on that, we are developing an algorithm. We are training an algorithm in order to developing a monitoring system for the starting fire in order to give alert to our monitoring room. We have also tested the different techniques. Satellite imagery is useful, but is complementary because it is not real time. We collect the data every 10 minutes from the sensors. LIDAR, it is useful, but you need an UAV or an helicopter flying the line. And IP cameras are very effective, but are much more costly than the small sensors, and they need more effort for maintenance. So in a cost-benefit analysis, it is a solution that on a larger scale, for us, it is not very useful. That's it.
Thank you very much, Maurizio. It was a fantastic presentation, and I think your approach as an integrated one, which doesn't just consider fires, but also all the other risks, is something that we can all really learn from. We have a lot of questions that have come in, so I invite you all to turn your cameras on. I have some that I've picked up to prioritize because you waited so patiently. I also have a question myself. Otherwise, yeah, free rein to raise your hands and to write into the chat. I'll start with Sebastian. You had two questions. One was about wind, which may have been answered, but feel free to ask again if not. And the other one for Maurizio on how these sensors, the ice sensors, are located. Sebastian, would you like to unmute yourself and specify your question here?
I can't hear the question.
Okay, no, me neither. So, Maurizio, one of the questions for you was, how do you define the location of a sensor for measuring ice deposits on the lines?
As deposit, we developed this sensor. This is patented. This is the pin for holding the conductor. Okay, the isolator is linked to this one. There is a cell in here, and we measure the weight of the power line. When the weight increases with the effect of the ice, we measure it, and we also detect the humidity and the wind speed, the wind angle with the power line, and we define altogether if there is the condition for ice on the line. So
I think, Maurizio, the question was more, how do you define where on the line to put these sensors? Do you put them on every line, or do you have high risk?
Sorry. I misunderstood the question. We have developed a risk map for the entire Italy. And we define the risk in high, medium, and low with a lot of fantasy. Depending on some historical data regarding the asset maintenance. We know that is a little bit faulty, as I said, because they give information only on the actual damages and not on the frequency of ice forming and melting.
Okay,
and this is an approach that we use for each kind of risk I mentioned.
Okay, thank you. The other question, I'm going to be cheeky and jump in myself. Something we didn't speak about so much today was vegetation management. Of course, this is a really key aspect of preventing fires along the lines. Now, one of the issues or one of the topics that we look at a lot at RGI is integrated vegetation management. So how can we move towards a more sustainable, ecologically close vegetation management to allow certain things to grow, but remove dangerous things from around the lines? I'd like to ask any grid operators in the room, to what extent do you feel that an ecological vegetation management is compatible with reducing wildfire risk? And here I immediately think of removing invasive species, supportive local species, maybe first a glance to Portugal, but also welcome anyone in the room who has experience with vegetation management. Who would like to take the question?
Well, I can try to answer. I'm more connected to asset management than vegetation management. But I would say in Portugal, we have some problems, and we have laws that force us to cut all the vegetation we have in some places. And lines are, we call it, one of those places to cut. As you saw on the image, some videos I showed, we cut a lot of trees and vegetation that we have on our lines. Is one of the problems we have is wildfires. One of the first problems we have on our network, because fires, and when they are passing through the line, they broke the insulation. They bring a lot of problems, as I showed under my presentation. So we spend a lot of money on cutting vegetation, but when we make this integration, this implementation, we do an integration of the vegetation. We try to make reconversion of the soil with a new species that grow slower, and then we can make a cheaper on the cut of the vegetation. I hope I could explain it with these words.
Thank you very much, Jose. Yeah, certainly that helps. I mean, you said slow growing vegetation, but of course, native species generally in Portugal, I know, are more resilient generally. The cork oak, for example, can withstand fires compared to eucalyptus or mimosa, which burns very quickly. Thank you for that.
Thank you.
Anyone else would like to comment on vegetation management? Otherwise, I would move to the topic of birds.
I could. Hello.
Okay.
From a grid operator in Germany.
Yeah, please go ahead. Yes, can you repeat what you said?
Yes, my name is Bernd Lang. I'm coming from Germany, from a grid operation called Bayernberg in Germany, and we're doing three things for preventing fires. We don't have them now, but they will come, I guess, with climate change. First, we do grazing, so we have deer and sheep and cows on our corridors. Second is we just make meadows, like blow. It's the three types we are trying to do and to prevent fires for the future.
Thank you very much, Bernd. The example that you mentioned of grazing of underneath the lines, I think, is particularly interesting, especially because of the knock-on effects. You know, rather than entering into an area and removing all of the vegetation with machinery, if you can allow rural actors to actually see this as a new grazing pasture land, this has benefits for them, but also then the inputs of sheep or cows onto the land through their feces brings new opportunities for the ecosystems.
It's helping the biodiversity. It's a high potential with ecological corridor management. We see it like this way, and it is.
Thank you for sharing your experience.
You're welcome.
I would like to address the topic of birds, and Brian McGowan, you asked a very relevant question here, so I'll give you the word straight away and you can ask your question.
Yeah, thanks, Anas. Can you hear me? Yeah. Okay. So yeah, I'm involved in a business that helps to resolve fire risk associated with wildlife electrocution, and that would include not just birds but also climbing animals that can bridge the gap between phases on electrical equipment. It's an issue predominantly on distribution networks because the phase-to-phase clearances are smaller, but it is an issue on transmission as well with nesting, collisions, etc. So I'm just curious to know, I was surprised not to see wildlife mentioned in any of the presentations. So I just wanted to ask your speakers if they've had any experience in this area. Please.
Thank you for your question. This is certainly something that we've dealt with and we speak to our members about, but first of all, I'll give the question to the speakers. Do you deal with the issue of wildlife electrocution leading to wildfires or causing sparks?
If I can speak for us, we have assessed together with our business line the risk mainly for operations, and this is not actually felt as a risk for operation of the power line.
Okay, and that's speaking as a TSO, where, as Brian said, I guess the risk is generally lower, but when we look at the lower voltage levels where the gaps between the components is lower, I know from my experiences in Germany, there's the one issue of larger birds becoming electrocuted, becoming trapped in the components and falling to the ground in flames and causing a fire. But also, as you said, specifically with storks, we see in many grid operators huge stork nests that are built and become extremely heavy over time. I know that one DSO in Germany, they monitor these stork nests very much. And indeed, if they get to a certain size that is endangering then the safety of the grid and the animals, they actually move these stork nests outside of the nesting season so that it doesn't cause any problem anymore. I also know that different grid operators handle the matter in different ways. In Belgium, they did a national sensitivity map to see where to address which species are most at risk and how to mitigate risk in terms of where they should put isolation, where they should put bird markers onto the lines. And in Germany as well, we work in a collaboration between NABU, the bird charity, and 7 grid operators to identify bird mortalities around the grid through a public portal so that we get a better idea of where these birds are dying and where then could be posed a risk. Indeed, in Germany, it's a legal mandate that on the lower voltage levels, if an electrocution takes place, they are legally obliged to retrofit this line.
Liam, if I can say something about that. First of all, just say that we also have some animals on the corridors helping us to cut all the grasses, and we have many projects and so on. We have also problems with storks. Is one of the 4 problems, as I said before. But they don't bring us problems with fire. They bring problems with the quality because they keep making problems with the line. We always every year we check where the nests are in worst place, and then we, with authorization of national authorities, we can change for a place, as you said, more safer for the bird and also more interesting for us. Is whether correlated also to a bird that has impact on the field. We had another project that we had fiber optics on the power lines. We are trying to implement something that when the bird has an impact with we call it EPGW on the fiber, we can collect some information and then know that we have impact on the line. So I have some project going on many subjects on the field.
Thank you very much, Jose. Please do keep us updated on these projects. I'd like to pass the word to Franco for the last question. You've been super patient, Franco. Please go ahead.
I'm not sure which question I should ask, but one of the questions that I was interested in was the fire propagation, the simulation. I think one of the things that adds credibility to the results of a fire simulation is having a fire footprint that actually resembled, so the predicted fire footprint and the real fire footprint were close matches of each other. Do the people who talked about fire simulation have evidence that the predicted fire footprint and the actual fire footprint matched each other reasonably well, which would add, credibility to the modeling?
I think I can answer that question. Thank you, Franco. It's a very interesting question. In fact, the models that we are using, they are semi-empirical models, meaning that some parts of it, they are the result of observation of thousands of wildfires. So they are born from this observation. Others are more physical-based models. So they go to the properties of the fire, the heat transmission, and so on. Of course, when we couple everything, we produce this model that might not be very accurate. That's why we use the artificial intelligence. And of course, we then compare with real fires, with prescribed fires that we also do in our lab and in the field. And we are constantly changing our parameters and updating our models to be as accurate as possible. So to quickly answer your question, yes, we do this. This is a very important part of our process of constantly updating our models. Yes.
Yeah. In my experience, the science of fire propagation is an evolving science, and we're learning much more about the intensity of fires and how fire intensity is increasing with climate change and the dryness of forest fires, which years ago wasn't an issue, but now with dry conditions, they become mega fires, whereas years ago. So it has to be a constant process of coming back and learning from actual events. So yeah, thank you.
Welcome.
Thank you very much. I see some really interesting questions in the chat about vegetation management and the use of LIDAR, also from you, Joe, that I'd really like to address. Unfortunately, we're out of time. But what I do see is that there's really a lot of appetite to discuss this topic. I would love to follow this up with another webinar later in the year. And as I've mentioned, this is part of a series. So please, I'll post the link in the chat again now, and you can register there for our newsletter, where you'll receive then updates about upcoming events. And we don't just talk about resilience, we also talk about bird protection, wildlife protection, vegetation management, all sorts of things. And you're always welcome to stay in touch. But for now, I'd just like to thank all of my speakers. You were excellent, and thank you to the audience for being so engaged. This was a really nice session, and yeah, I'm very glad to keep this topic living among us. Thanks a lot, and enjoy the rest of your day.
Bye-bye, everybody.
Bye.
Thanks a lot. Bye.
Thank you very much. Bye-bye.
Thank you.
Bye.